Good morning, Year 4. It is Friday and I hope you've had a really good week. We are going to do some maths in a minute, but before we start, let's jump up to our feet and get ourselves moving. Okay, let me just start the music. Right, okay, so what I want you to do to start is I want you to run the box quite slowly, okay? And if you want, you can get those arms going. Well done. Okay, then punch up. That's right, punch up the side. And punch down. Well done, everybody. Okay. Now, let's do some little jumping. Swinging those arms as hard as you can as well. Imagining there's a line on the floor that you're trying to jump over. Okay. You can do it quickly if you're good at it. If you get tired, just go a bit slower. Keep yourselves moving. Well done, everybody. Right, we're going to do a few lunge jumps. So we go forward and then swap. Okay. See how many of those you can get done. And remember, always wearing a smile. Keeping yourselves going. Well done. Okay. Brilliant, everybody. Right, we're going to opposite hand to opposite foot. Okay. You make a star shape. Can you come up? Well done. Okay. Now we'll do opposite foot again. And as you do it, get your arms high and bring them down. So we're using both our arms and our legs. Get all of our bodies moving. Brilliant. Right, now again, high knees kicking back. Okay, you can see I'm going to be kicking my bottom. There you go. And then you can start punching as you do that as well. Well done. Okay. And what we'll do is a couple of what we call ice skaters, where you go from side to side. Okay? You can do that. You can jump as high and as far as you can. You can keep it small. You're getting a bit tired. And you can punch your arms. You can hold your arms and hips. It doesn't really matter. Okay. Well done, everybody. Right. Are we ready to get started? Okay, so yesterday I left you with this question: how many squares were there in total? Well done if you managed to spot 14. There's obviously the 9 that you can see, and then there is a larger square of 4 there, which makes 10, another larger square of 4 there, which is 11, another larger square of 4, which is 12, another square of 4 there, which is 13, and of course we've got the square itself, which makes 14. Okay. Right, today we are going to find decimal equivalents for fractions. So we are going to be looking at some particular fractions and see if we can work out how they would be written as a decimal. We did it with hundredths and with tenths, and now we're looking at some other fractions. So the date is the 5th of February, 5th of the 2nd, 21. I would also like you to write the date and mark really neatly, underlining it, and pause the video so you can get that done properly. So first thing, we've got a 5 a day. The questions in red are for circles and squares. The questions in black are for pentagons and hexagons. As I said, if you think you want to try the other questions, I don't mind which ones you do, but that is just a guide. So pause the video, have a look at the questions, and then we will go through the answers. Right, so question 1 for circles and squares. I have 18 biscuits and eat a third of them. How many do I eat? Hopefully you have written a third of 18. Now we've talked about this. You could do 18 divided by 3, which equals 6, or you could have drawn your bar model and split it into 3 parts and shared it out, shared the 18 out into thirds, and you would have found that you had 6 in each third. Okay, if for pentagons and hexagons, just quickly go back to the question, I have 27 biscuits and eat 2/9 of them. How many are left? So we can find 2/9 of 27, which I've written up there. Okay, so we can do 27 divided by 9, which equals 3. We take that 3 and we multiply it by 2, which is 6. That's our 2/9. Okay, that's the amount that have been eaten. I want to know how many are left. I wonder how many of you remembered then that if 27 was the total amount and that's how many were eaten. We needed to do 27, take away 6, which is 21. Well done if you remembered all of those steps. Okay, question 2 was, what shape is this? Okay, it is a parallelogram. Okay, it looks like a rhombus. And if you put rhombus, I will allow that as well. However, it's really important to remember the difference. A rhombus, all the sides are equal, whereas a parallelogram has 2 pairs of parallel sides and 2 pairs of equal sides. Okay, I could change that slightly and make it look a little bit less like a rhombus. Okay, you can see, although it still does a bit, it's a little bit of a difficult one to judge, I'm afraid. So if you put rhombus, I'll let you have it, but I think it is a parallelogram because those 2 sides are slightly shorter than those 2 sides. Okay. Question 3, mark the right angles in the shape. So hopefully there is only one, you would have put it here. Okay, and that's how we mark a right angle. Right. Question 4, we've got column subtraction. So circles, you had 764, take away 326. And pentagons and hexagons, you have told I spend £3.57. How much change do I get from £5? So you need to do £5, take away £3.57. So I'll just show you both of those. So circles and squares, okay, there they are. You did 4, take away 6, you can't do, so you need to exchange from the tens, that becomes a 5. 14 take away 6 is 8. 5 take away 2 is 3, and 7 take away 3 is 4, 438. The question about the change, 0 take away 7 we can't do, so we would go to the next column, but there's nothing there, so we need to go to the 5. That becomes a 4, and we can't jump that straight to the ones column, or in this case, the hundredths column. We put it into the tenths. We then cross that off so it becomes 9, and that we then move that across. So we've now got 10 take away 7 is 3, 9 take away 5 is 4, and 4 take away 3 is 1. So our answer is £1.43. Right, and question number 5. Oh, 2 seconds, there we go. We've got a column addition. So we've actually got the same question. 4,673, add 3,273. So 3 add 3 is 6. Let me just show you a bit more clearly. And 7 and 7 is 14. So 4 there, 1 underneath the hundreds. 6 and 2 is 8. Add 1 more is 9. 4 and 3 is 7. So our answer is 7,946. Right, as usual, depending on how many you got right, we have got some exercise. So just check how many you got, and then this is what you've got to do. You've got 30 seconds of plank if you got 1 right, 2 star jumps if you got 2 right, if you got 3 right, high knees where you're jogging, bring your knees up, 4, you've got to do sit-ups, and 5, you get to choose. Okay, your time starts now. Off you go. Like I say every day, keep yourself moving, however hard you're finding it. Even if you only get a few done, it's better to keep moving rather than giving up. Okay, you've already had 15 seconds. You're halfway. So keep yourselves going, everybody. You're doing really well. Okay, we're down to our last 10 seconds now. Keep that body moving. Okay, nice, lots of energy. Down to our last 5, 4, 3, 2, 1. Well done. So what we are looking at today is we are going to try and find decimal equivalents for particular fractions. I've drawn here a number line, okay? It goes from 0 to 1. I wonder if we can think about the fractions that would go at these points. Pause the video and just have a think if you can work out what fraction might go here. Look at its position in relation to the 0 and to the 1. Well done if you thought that that should be 1/2. Okay, that's brilliant. It's halfway between the 0 and the 1, and it's the halfway mark. Now we've got 2 other markers, okay, and they are evenly spaced. Okay, so in other words, our line from 0 to 1 has been split into 4 parts. Pause the video and see if you can write down what you think this would be as a fraction and this point would be as a fraction. Well done if you worked out that the line has been split into quarters. So we've got 1/4 here. This would be 2/4, but having done our work on equivalent fractions, we know that 2/4 is the same as 1/2, and this is 3/4. Okay, now what we are going to do is we're going to try and do an investigation to find out the decimal equivalents of those numbers. Okay, so what I want you to do is there is a piece of paper in your in the folder for today, and it's called Activity 1. Let me just stop sharing it so I can show you. And it looks like this. Okay, and what I want you to do now is you might need to pause the video or stop it, and I want you to work through this, because if you work through this, it will enable you to work out what the decimal equivalent is for 1/4, 1/2, and 3/4. So I want you to work your way through that. And then once you've got your answer, watch the video again and we will move on with the next thing. So this is the first activity for today. So pause your video and have a try at that. What you will need to use to help you is a place value grid. So when you get onto this activity, if you want to draw yourself a place value grid that looks like that, that will help you with the final part of the investigation. So have a pause and we will come back. Right, welcome back. What did we find out? Did we manage to find out what 1/4, 1/2, and 3/4 is in decimal, as a decimal? Did we find out that 1/4 was 0.25? Well done if you did. And the way we worked through that was that we know that a quarter, when we shaded it in on a 100 square, was 25 hundredths. And we know that 25 hundredths can be written as 0.25. Did we work out that 1/2 equals 0.5? Again, when you shade in the squares on a 100 square, you shade in 50 squares out of 100. And 50 out of 100 can be written as 0.5 or 0.50. And did you work out that 3/4 was 0.75? Because when you shade in the 75 squares on the 100 squares, it becomes 75 out of 100. And then you can put that back in your place value grid and see that it is 0.75. Really well done if you worked that out. This little bit of information here is something you need to try and keep in your memories, okay? So that when you are asked, what does 1/2 equal? You will just know it is 0.5. You've proved that by doing this activity. And now we've just got to try and remember this little fact. Well, you know that 1/4 is 0.25 and 3/4 is 0.75. Okay, so moving on to a number line, because we are now in our second activity, we're going to be putting fractions and decimals on a number line. When you're presented with a number line, you need to see how many parts it is split up into. Now, each of these number lines goes from 0 to 1, okay? And so if we look at the first example, how many parts are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what do you think the value of each of these sections is going to be across the number line? Well done if you've worked out or thought that it is 1/10. So as we are counting on in tenths, because we're going from 0 to 1, what will the next one be? Well done if you have spotted it will be 2/10. And so on. 3/10, the third one along. 4/10 will be the next one. I'm sorry, my writing with this can't quite keep up with how quickly I'm saying it. Then halfway through, we're at 5/10, which we now know is the same as a half. Okay, 6/10, 6 parts out of 10, 7/10. Okay, nearly there. 8/10 and 9/10. And as we've already talked about over this week, when we get to 10 out of 10, that's the same as 1 whole. Now you could go back along now and put your decimal equivalents of each of those numbers. So I'd like you to pause the video and do that. Well done if you managed to get those decimals, 0.1, 0.2, and all the way up to 0.9. Right, let's have a look at the next number line. We're at 0 here and 1 here, but this time, how many parts has the line been split into? Well done, it's been split into 4. So each section is 1/4. So we count on in quarters, 1/4, 2/4, which we know is the same as a half, 3/4, and 1. Now, from what you've just done, we know the decimal equivalents for those amounts. So pause the video and just remind yourself what they are. Okay, well done if you remembered that 1/4 is 0.25, 2/4 is 0.5, and 3/4 is 0.75. Right, I've just put an extra number line in down here. Let's see if we can get the fractions onto this. How many parts has the line been split into? 1, 2, 3, 4, 5. So now we're talking about fifths. Well done if that's what you just said. So we've got 1/5, 2/5, 3/5, 4/5, and 1 whole or 5/5. Now you can do this with any number line. If it has been split up into an equal number of parts, you can say what the fraction is along the number line. Right, for your second activity today, there's a sheet in the folder that says for all groups, but there are different stars on it. Circles, I would like you to do the 1-star activity, squares, the 2-star activity, and pentagons and hexagons, try the 3-star. Each of the activities is a number line, and there are some fractions that you need to place in the right place on the number line. If you're able, I would then like you to give the decimal equivalent of that. And if you're feeling really confident with this, maybe you can add in some extra fractions that haven't been shown on that number line. But if you're going to do that, make sure whatever fraction you're showing, you split that number line into equal parts. Okay, enjoy doing the rest of your maths today. Just before I go, it is Friday, so I have not got any more riddles for you today. I wasn't going to give you one to ponder over the weekend, but just want to say have a brilliant weekend. Enjoy yourselves, have a rest because you've all been working so hard. So finish today and then have a brilliant time relaxing, and I will see you all again on Monday. All right, take care everybody, see you soon. Bye-bye.